right, so let's integrate and evaluate. And it's the fundamental theorem of one part of the fundamental theorem of calculus that allows us to find the antiderivative and then substitute. So now let's do this one. All right, so we're going to, integrate, we increase the exponent by 1. We're just using the power rule. So we have x to the 4th divided by 4. So increase the exponent by 1 and divide by that amount. To take the derivative, right, you move the exponent, you multiplied by the exponent and decreased it by 1. So now we got to do the opposite. So we got to divide and increase rather than decrease. Right, so that would be x to the 4th divided by 4 plus, and to integrate at 1, that would just be x. Right, and we're going to evaluate that from -1 to 3. So we'll plug in the 3 and simplify, and then we'll plug in the -1 and simplify. And use parentheses. So we have 3 to the 4th divided by 4 plus 3. Right, so we evaluate everywhere at 3. And then we evaluate everywhere at -1, and then we substitute. So -1 to the 4th power divided by 4 plus -1. Right, so 3 to the 4th power would be 81 divided by 4. And then we've got to change 3 so it has a common denominator, so we can combine that with the 81/4, so that would be 12/4 minus. Right, so if we square raise -1 to the 4th power, it's going to be a positive 1/4, and then minus 4/4, so we can combine. So 81/4 plus 12/4 would be 93/4 minus. So 1/4 minus 4/4 would be a -3/4, so we're going to have 93/4 minus -3/4. That's the same as 93/4 plus 3/4. So that's going to be 96/4, and that does reduce to a 24. And there we go. And we could, if we wanted to, we could use the limit of Riemann sums, right? Because that's what these are all based off of. But on this lesson, we're going to use the antiderivatives instead. All right, and here we have another one, and I think we did this one on a previous lesson, but it's got a nice picture, so I'll do it one more time. All right, so whose derivative is sine x? That would be negative cosine x, and put use parentheses so you don't forget to distribute when you substitute. So we're evaluating that from 0 to pi, so we have negative cosine pi minus cosine 0. So that would be cosine pi is -1. Cosine 0 is 1. So we have -1 minus 1. And that would be -2 or just 2. Right? And we can see that it's above the x-axis. If we evaluate it all the way to 2 pi, then the negative and the positive would cancel each other out. All right, so here's our next one. First of all, let's rewrite that. We have a negative exponent in there. We have a radical in the negative, which would be a negative exponent. We want to rewrite that. We don't want something in the denominator. We want to rewrite that as a negative exponent. And we also don't want radicals, we want exponents, right? So let's rewrite that as the integral from 8 to 27, and this would be x to the 2/3, I'll put that in parentheses, minus 6x to the -1/3, right? And that's dx. All right, so now let's integrate. All right, so we have we're going to increase the exponent by 1 and then divide by the same thing. So 2/3 plus 3/3 is 5/3. So this will be x to the 5/3 divided by 5/3. Let's put parentheses around all this. Minus, right? So -1/3 plus 3/3 would be 2/3. So minus 6x to the 2/3 divided by 2/3. And we're evaluating that from 8 to 27. These are perfect cubes. Now, dividing by 5/3 is the same as multiplying by 3/5. So we have 3x to the 5/3 divided by 5 minus, and then dividing by 2/3 is the same as multiplying by 3/2. So that would be 3/2 times 6x to the 2/3 power. And we're evaluating that from 8 to 27. Right? Let's change those exponents to radicals because it'll be a little easier to simplify. So we have 3 times the cube root of 27. And so I'm going to plug 27 into everything, and then we'll plug 8. And while we're at it, we'll simplify this. All right, so that's just going to be a 9. So we have 3 times the cube root of 27 to the 5th power divided by 5 minus 9, and then the cube root of 27, don't forget my parentheses, 9 times the cube root of 27 squared, and then there's nothing in the denominator here. All of that minus 3 times the cube root of 8 to the 5th power divided by 5. And don't forget my parentheses. And then minus 9 times the cube root of 8. And that is squared. And close our parentheses. All right, so now let's simplify. Cube root of 27 is 3. 3 to the 5th power is 243. And then, so this would be 243, but times 3. So 240, I think it's 729. Yes, 729 fifths. And so all it was is plugging into a calculator. Minus, and that would be the cube root of 27 would be 3. 3 squared is 9. 9 times 9 is 81. Minus, and the cube root of 8 is 2. 2 to the 5th power is 32 times 3 would be 96. So 96 fifths. Minus, cube root of 8 is 2. 2 squared is 4 times 9 is 36. Rather than give everybody the same denominator, why don't we just distribute the negative and we can combine like terms, and then if we need to, we'll rewrite. All right, so this would be 729 fifths minus 81 minus 96 fifths and plus 36 equals. All right, so just distributed the negatives. All right, so 729 fifths minus 96 is going to be 633 fifths. And then we have negative 81 plus positive 36. So that's going to be a negative 45. And let's change that to fifths so that we can combine it. Right? So that would be 225 fifths. So final answer, it's going to be 408 fifths. There we go. All right, so not too bad. Probably the computation was the hardest part, right? And hopefully there's no math errors. That can be, so take your time when you're doing the computation so you don't make any silly math errors. Here we have a very similar one to one we did before. Only the interval has changed. So this is the integral of cosine x from 0 to pi halves. All right, so that, and don't forget your dx. All right, so we'll integrate. That's going to be negative sine x from 0 to pi halves. And now we're not going to forget the negative, so sine pi halves. Oh, I'm sorry, this isn't one like we had before. We'd had the derivative of, I'm thinking of taking the derivative of cosine x. The derivative of sine x is cosine x. So I was thinking of taking the derivative of cosine x, which is negative sine x. There's no negative here. This would just be sine x from 0 to pi halves. So that would be sine pi halves minus sine 0. Sine pi halves is 1, sine 0 is 0, so 1 minus 0 is 1. And that makes sense, right? Because it's the same, it's half the area when we had sine x, right? Back when we had the area under sine x from 0 to pi, well, that's half of the area, right? And that's the area under cosine x, right? Same area, just shifted, and it's only half as much area. All right, so there we go. There's that one. All right, so now let's try the next one. All right, so now the only way you can integrate this, because there is no undoing the quotient rule, right? You can't undo the quotient rule. There are many integrals that we cannot integrate. We don't have ways to undo the rule. All right, so you can't undo the quotient rule, but you could simplify here. All right, so we're just going to, first of all, I'm going to rewrite that radical as an exponent. So we have the integral from 1 to 4, x to the 1/2 plus x minus 2x to the 4th, all divided by x squared dx. And then to simplify, you can divide each of these terms by x squared, right? As long as there's only one term in the denominator, you can just divide everybody, and to divide, you subtract exponents. So it's the integral from 1 to 4. 1/2 minus 2 would be x to the negative 3/2, plus 1 minus 2 would be x to the negative 1. Now, I'm going to rewrite that as 1 over x, because now we see how to take it. X to the negative 1 power is 1 over x, and its antiderivative is going to be natural log of x. Right? So it's not, that one's not a power rule. And then this would be minus 2x squared, right? Because we're dividing x to the 4th by x squared. All right, so now we can integrate. All right, so we increase by 1 and we divide by the same thing. So this would be x to the, so negative 3/2 plus 2/2 would be negative 1/2, and then we divide by negative 1/2 plus natural log, there we go, of x. I'll put it in absolute value bars, minus 2x, we increase by 1 and divide by the same thing, and we're evaluating from 1 to 4. So we'll simplify, and then we'll plug the 4 in, and then we'll plug the 1 in and subtract the 2. So this would be, and I'm going to rewrite that as a radical. It'll be easier on the simplifying. So dividing by negative 1/2 is the same as multiplying by negative 2. So negative 2 divided by square root of x plus natural log, oops, got one too many things in there, natural log of x, let's put parentheses around it, minus 2/3 x cubed, and we're evaluating all of that from 1 to 4. So we have negative 2, in parentheses, negative 2 divided by the square root of 4 plus natural log of 4 minus 2 times 4 cubed divided by 3. Take all of that and now plug in the 1. Minus negative 2 divided by the square root of 1 plus natural log of 1 minus 2 times 1 cubed divided by 3. And I'm just going to move up because I guess I can keep going a little bit. All right, so I just moved the screen down. So this would be negative 2 divided by 2, square root of 4 is 2. So that's going to be negative 1 plus natural log of 4. This will be 64 times 2 would be 128 thirds. Minus, so negative 2 divided by the square root of 1, that's just negative 2. Natural log of 1 is 0. And then minus, and that's just going to be 2 thirds. So again, why don't we distribute the negative, and then we'll combine. So we have negative 1 plus natural log of 4 minus 128 thirds. Minus a negative 2 is plus 2. And then plus 2 thirds. All right, so we can combine negative 1 and the 2. That's going to be 1 plus, minus 128 and 2 thirds there. That's going to be minus 126 thirds, which we could simplify, plus natural log of 4. So 126 thirds. That's going to be 42. So 1 minus 42. So I'm going to write the positive one first. Natural log of 4 minus 41. And that's our answer. All right, assuming no computation errors. All right, and I, best as I could be to not make any computation errors in these. All right, so that's that one. And I wouldn't simplify that any further. I would leave it the exact answer. All right, let's look at the next one. Properties. All right, so we're going to do some properties now. All right, so we have the integral of f of x dx from a to b be 3. The integral of f of x dx from a to c be 5. We want to find, first of all, the integral of f of x dx, but from b to a. Well, that we just have to do the reverse. So this is the same as negative. I shouldn't say reverse. We have to do the opposite. The value is going to be the opposite. So it's going to be negative, and if we make that negative, we can flip the limits of integration, make that a to b instead. F of x dx, and so that's going to be, instead of 3, that'll be negative 3. Next one. All right, so we have the integral of f of x dx from b to b. Well, since the change in x and the limits of integration is 0, so is the definite integral. And that one's done. Number 3. The integral of f of x dx from b to c. And let's see who does that match. Okay, so b to c. We have a to b. We have a to c. So if we took a to c, we don't want that much. We only want b to c. And we subtracted a to b, or excuse me, yes. These don't match. Hold on. X dx. All right, now the only problem is we need them to match, and they don't. So let's rewrite this one more time. All right, so if we want to add and subtract, right, then I can add a to b, and then I can add b to c, right, and that would give us a to c. So let's actually just write that. So if it's from A to C, sometimes it's easier to break the problem down first, and then let's see what we need. So from A to C, f of x dx is the same as A to B plus B to C, right? So now they match up. All right, and we were given A to C. That's no problem. We're given A to B, and we want B to C. Yep. So now if we just subtract from both sides, now, okay, so I think it's the same thing we had before, but I think it's easier to see now. So f of x dx minus, oops, got a random line here, minus f of x dx from A to B equals f of x dx from B to C. Now, it's the same thing we had before, but I think it's easier to see it now, right? Whereas before, when I didn't write the first step, I don't know if you would have saw it as easily, right? So that means f of x dx from A to C is 5. And then from A to B is 3, and that will give us from B to C. So 2 equals the integral from B to C. All right, I think it's a lot easier to see it that way. Whoops, what happened here? All right. All right, so now let's do another one. Oh, wait, didn't do them all. 1, 2, 3, 4. We're missing 4. Let's do 4. And we'll do that up here. All right, so f of x dx from C to B. We have A to B. Or do you have, oh wait, did I, yeah, we did C to B. Now we did B to C, we want C to B. Well, we already have C to B, which is 2. 4 is just the opposite. So actually, let me write it, not 4 equals. I'll write it up here. So 4, this looks like an F. The integral of f of x dx from C to B is just the opposite of the integral of f of x dx from B to C. And we have B to C, so, and B to C was, let me write that nicer. I don't even know what that little thing in there was. From B to C was 2, so this would just be -2. Try to make that a little nicer. I guess as nice as it's going to look. All right, so if you have questions, let me know. All right, but you're using the properties of the integrals and the information we're given to rewrite these, and so that we can use that information and find the answers. Find these definite integrals. We're given that 2 to -5 f of x dx equals 14, and -5 to 2 f of x dx is -5. We want from -5 to 2 of, oh, excuse me, I said f of x g of x. All right, so all we have to do here is combine them, right? So the integral of a sum is the same as the sum of the integrals, right? And the coefficient can be pulled out. So this is the same as 2 times the integral of f of x dx from -5 to 2 minus 10 times the integral of gx dx from -5 to 2. Now, the only way you can combine these, by the way, is if the limits of integration match. So limits of integration must match. Right? So now this would be 2 times 14 minus 10 times -5. So that's going to be 28 plus 50, or 78. Okay. Here's the next one. All right, so they match, right, from -1 to 7. And this one was 7 to -1, right? But we could rewrite this one, right? So from 7 to -1, that doesn't match -1 to 7. But this is the same as negative integral of gx dx from -1 to 7. So if we put a negative in front, we can switch the limits of integration, and that would be therefore -2, or 2. All right, so now we can do this one. We can factor out the coefficients and write this as 2 integrals. So this would be the integral of 1, or it's just to be 1/2 times the integral of f of x dx from 7 to -1. And by the way, I could have rewritten this one as well. It didn't matter which one I rewrote. They just had to match. So I opted to write the second one over because, well, it was negative anyway, and so now we made it positive. So 7 to -1, and then plus 4 times, and actually this should be, let's include the negative in there. So -4 times the integral of, we just know when we plug it in, it's going to be a +2, not a -2, from 7 to -1. But we don't want to rewrite this incorrectly, right? So we want to make sure we show it's a minus, right? And of course, a minus and -2 would make that a +2. And then g of x dx. So this would give us 1/2 times 4 plus, and let's actually put a minus in there, minus 4 times -2. So we know that's going to end up being a +2 as we wrote up there. But since we've already got the negative in there, let's just leave it with the negative in there. And so that would give us 2 plus 8, and that's going to be 10. All right. And you see, if we switched the other ones, right, the other one, we would have the exact same answer. Right? And I think this one looks good. And that was all of them on this page. Yep. All right, so here's some more. And we're given some information there. F of x dx from 0 to 1 is 1. F of x dx from 0 to 2 is 4. And f of x dx from 1 to 4 is 7. So we want to find, first of all, number 1, f of x, the integral of f of x dx from 0 to 4. So then we would just add the integral of f of x dx from 0 to 1 plus the integral of f of x dx from 1 to 4. So notice that the end on the first one is the beginning on the other, right? So we matched them up, and now we just add those together. So that would be 1 plus 7 or 8. Number 2. So we want from 1 to 2. We've got from 0 to 1. We've got from 0 to 2. Right? So together, the integral of 0 to 1 f of x dx plus 1 to 2 f of x dx equals 0 to 2 f of x dx. So if all we want is 1 to 2, then we're just going to subtract the 1 to 0 from both sides. So, and I think it's easier for you to see if I do it this way too. The integral of f of x dx from 1 to 2 is the integral of f of x dx from 0 to 2 minus 0 to 1. So notice now it's the bottoms that are matching up. But if we write it the way they line up from 0 to 1 and 1 to 2, we see if we subtract 0 to 1 from both sides, we're going to end up with just the 1 to 2. So this would be equal to 0 to 2 is 4 minus 0 to 1 is 1, and that's going to be 3. And there we go. So 1 and 2 are done. I need more space. I may have to move the screen, and hopefully, though, I'll still be able to see the top. Oh, I have a, let's get rid of that. And I think maybe we can just move this over here. That fits. It didn't take up that much space. All right, number 3. All right, well, that's a nice, easy one. All right, so notice the limits are just switched. So 3, f of x, the integral of f of x dx from 4 to 1 is just the same as negative f of x dx from 1 to 4. So that would be negative 7. And then the last one is 4, and that's from 2 to 4. Let's see, we've got 1 to 4, we've got 0 to 2. So, let's see, let's squeeze this one in here. If we take 0 to, what was we looking for? We were looking for 2 to 4. So if we take 0 to 2 plus 2 to 4, we end up with, no, excuse me, 0 to 1 plus 1 to 4. All right, so 0 to 1, f of x dx, plus, look at all my numbers there, 1 to 4, f of x dx together equals, or not 1 to 4, excuse me, 2 to 4. Oh, wait a second. No. Ignore that. Forget what I said. Here, I think I need more space, and then it won't make any silly errors. I am going to clone this page real quick so that I can see the top of the page. And we'll get rid of all the ones that are already here. Oops, no, wrong page. Okay, so now we'll get rid of all of these. So I've got enough space and I'm not cramming it in. Okay, so number 4 here. I want to be a little creative here. We want to get from 2 to 4. We got from 0 to 1. We got from 0 to 2. We got from 1 to 4. But we want from 2 to 4. So let's see here. So we can put the one with the 0 to 1 and the 1 to 4 together, right? But if we were to subtract it, right, that would leave us with, wouldn't give us 2 to 4. We can put the 0 to 2 together. So yes, 0 to 2 plus, all right, here we go. if we take the 0 to 2 and subtract the 0 to 1, we're going to be left with the 1 to 2. We don't want the 1 to 2. We want 2 to 4. Yeah, we want to subtract the 0 to 1. I got it. Never mind. So 0 to 1. All right, here. This one is a tricky one. We want 2 to 4. We've got 1 to 4. And we have, so what could we add or subtract to get to 2 to 4? So if we take off the 1 to 0, that's not going to help at all. If we take off the 0 to 2, they don't match. But if we take off the 1 to 0, all right, so now they match at the bottom. So now if we take off but see, notice we're taking off, oops, and that should be 0 to 1. So that's not going to help us, right? That won't help us. That won't get us from 2 to 4. We've got a 0 to 2. But now that doesn't match at the bottom there. So So 1 to 0. So if we take the, oops, why do I keep doing that? I keep wanting to make my integral sign an F. All right, here we can get this. So sometimes it's tricky. You may have to try different things. So we got f of x dx. If we take the 2 to 0 minus the 0 to 1, we'll be left with the 1 to 2. Right? Because if we add it the other way, right? So 0 to 1 and then plus 1 to 2 gives us 0 to 2. So that gives us 1 to 2. We're getting closer, but we want 2 to 4. If we take that, take the 0 to 4, and subtract the 1 to 2, now we'll be left with, oh, excuse me, not 4 to 0. It'd help if I don't write it down as 4 to 0. Take the 4 to 1 and subtract the 1 to 2. Now we've got the 2 to 4. There we go. So sometimes it might be helpful to break it up. All right. So now let's figure out each part. All right. So here's our whole long answer for number 4. All right, and you take a look at it and make sure it makes sense to you afterwards. All right, so 0 to 2 minus 0 to 1, this here would be 4 minus 1, which is 3. So 4, f of x d, the integral of f of x dx from 1 to 4 minus 1 to 2, which we just found, will give us what we're looking for, 2 to 4. So that would be 7 minus 3, or 4. 4 is our answer. Right? So that one is a tricky one. All right? And that's the last one I have for in this particular lesson. Ooh, that took us a little longer. All right, so I'm going to end this podcast now. Thanks for watching. Bye for now.